All right, we are doing 6-6, the last section of chapter 6. You can go ahead and do the warm-up on your own. Just remember that when we have these absolute value brackets, that means you need your two equations, one with the positive and one with the negative. And when you do the negative with the inequality, you got to flip that around as well. We are graphing linear inequalities today. So everything else we've done so far this chapter has just been one variable, and so we've graphed them on the number line. Now we have two variables, an x and a y, and so we have to graph them on the coordinate plane exactly like we did all of chapter 5. So we have to remember that to graph a line, we need two things. We need the slope and we need the starting point. Okay, so we're going to put it in slope-intercept form, y equals mx plus b, where m is your slope and b is the y coordinate of your y-intercept, which will give you your place to start. Okay, so slope, and then the y-coordinate of the y-intercept are your starting point. We're going to just practice that really quickly, and then we're going to move to the actual parts that have to do with the inequalities. So this one is already ready to graph. We know that because it says y equals, so we can get our slope. So m is negative 2/3, which means it'll be going down from left to right because it's negative. Our starting point is 0, positive 1 because of the plus 1 at the end. So start up at 0, 1, plot your point. And then your slope is negative 2/3. So down 2, right 3. The opposite of that is up 2, left 3. And then once you have all those plotted, you connect them. Oops. All the way through your graph. And put your arrows at the end. That's it. So what we're going to do today is obviously instead of having an equal sign, we are going to have an inequality here. So greater than, less than, greater than or equal to, less than or equal to. So similar to when we did it on the number line, you have to pay attention to what kind of a line you're drawing, just like you had to pay attention to if your circle was open or closed. You have to pay attention to whether your line in this case is dotted or solid. And we can't just leave the line, we have to do some shading just like we had to go in one direction or the other on the number line. So two things really similar, but we just have to do a couple extra things to change it around. So there's an exploration in your notes. So on the actual notes assignment, the 6-6 notes assignment, the exploration is linked to that. You can go ahead and put them in this document if you want, or you can open it separately, it doesn't matter. But go ahead and go there and complete that first. Now that we have done the exploration, we should know that where we're going to shade. Okay, so here are our steps. So we're going to put it in slope-intercept form, make sure the y is by itself, just like before. Then you are going to graph your line, but you cannot just connect your points to make your line right off the bat. You have to make sure you know if your line is going to be solid or dotted. So your line is solid if it's equal to, okay? So if your inequalities have the equal to underneath, then the line you draw is going to be solid because that gets to be included. That gets to be part of the solution set, just like the line or the circle was solid when we did it on a number line, okay? So solid line underneath the inequality means the line you draw is solid. Dotted if there's no line underneath the inequality, okay? So dotted for these because there's not an equal to. It's the equivalent of the open circle. You shade above the line for greater than and below the line for less than, okay? And when we're talking about lines, if you have a line, the above portion is where you would walk if it were a hill. So if this were a hill, I'd be walking up here. So this is my above. Okay, so wherever you're looking at, try to think of it like that, like a hill. So if it's for the ground part, it's going to be the below. If it's where you would walk, that's the above. Okay, so here's our inequality. We can see by looking at it that it is not yet ready to graph. So I have to add the 2x to both sides to get the y by itself. Adding, be careful because we're still dealing with inequalities. Adding inequalities does not change your sign, so we're still less than or equal to a positive 2x minus 4. So now I can get the information I need. So the slope of this line is a positive 2 over 1, and my starting point is going to be 0, negative 4. Okay, so I'm going to go to my graph, and I'm going to start at 0, negative 4. So down 4 on the y-axis, plot the point. The slope is a positive 2 over 1, so that's going to be up 2, right 1, or down 2, left 1. Kind of run out of room there. I'm just going to put as many points as I can fit on the graph, so I'm going to continue to go up 2 over 1, over to the right 1, just to make it a little bit more accurate. Before I just jump right into connecting it, I have to look at my inequality. So this is where it starts to change a little bit. My inequality was a less than or equal to, so the fact that there is that line underneath means the line I get to draw is solid. So I am going to connect these with a solid line. Okay, but we are not yet done because we do have to shade. Okay, so we have to figure out whether we're shading above or below. My final answer was a less than or equal to, so the less than is going to be below. So again, if this were a hill, I would be walking up this side of it, so that's the above. Where the sky is the above. Where the ground is the below. So I wanted to go below for the less than, so I'm going to shade everything underneath that line. Oops. Because it's less than. Okay? So all the underneath we shaded, and then we're done. So it's solid because of the line underneath, and we went below. Okay, so this told us solid and below. Okay, let's look at this one. The y isn't by itself, so we're not ready to graph it yet, so we're going to add the 4x over. Adding with inequalities doesn't change it, so when we add the 4x, we just get a positive 4x plus 6, and it's still a greater than sign. We are not done yet, so we have to divide everything by 2. Now we're dividing for inequality, so we stop. What kind of a number are we dividing by? We're dividing by a positive 2, so this is still going to stay the same, but you have to be aware because none of those rules have changed. So 4x divided by 2 is 2x, plus 6 divided by 2, which is 3. Now that the y is by itself, I can identify everything I need. So my slope is 2 over 1, and my starting point this time is 0, 3. So then I go ahead and I go up 3 on the y-axis. This part is exactly how it was before. And my slope was a positive 2 over 1, so up 2, right 1, or down 2, left 1. And then we just keep going. I'm just going to keep going until I get to the end of my graph. Before I just get excited and go ahead and call it a day and connect those, I have to look at my inequality and see what it tells me. This is a strictly greater than sign. Oops, that's a little big. So if it's strictly greater than, it's going to tell me that it is going to be dotted because there's no solid line underneath, and greater than is above. So we are going to do a dotted line above. I think Notability does dotted lines for you now. Oh, it does. Pick that one. Okay, we're going to go dotted and above. So Notability does the dotted lines for you now, or you can just do the dashes. But there's your dotted line. What's it look like? You could do that dotted either one. Dotted line. And we still have to shade. And this one is above, so again, where the sky would be if I were walking up the hill is this way. So this is my above, so this is where I shade, up here. And then that's it. All right, let's look at this one. This one's not too different. You would do this one on your own. On your own. Okay, y is greater than or equal to 4. There's nothing to solve here. It's only a y, which means that we have to go where y is 4. So our y is 4, up 4. 1, 2, 3, 4. Our entire line has to be up 4 when there's only a y that is a horizontal line at that value, okay? You can put as many points as you want to cross. Then we look and see, what does this inequality tell us? This tells us that it's solid because of the line underneath, and it's greater than, so we are going to be shading above. So we're going solid, above. So I draw my horizontal line, line it up, and above because it's greater than. And that's it. Okay, we'll do this one. We have to start by subtracting the 1 because it's a positive 1. Be careful, that leaves you with a negative 1y, okay, there's a 1 here, is greater than x minus 1. We aren't done yet because you still have a negative with the y, so we have to go ahead and divide by a negative 1. We're dividing, so we stop. What kind of a number are we dividing by? We're dividing by a negative. So this does flip your inequality and make it a less than sign, and then divide both these parts by negative 1, which gives you a negative 1x plus 1. Now our slope is a negative 1 over 1, and our y-intercept is 0, positive 1. Again, all of that stays the same as it was before. So we go up 1, plot your point on the y-axis, and then down 1, right 1, or up 1, left 1. I put as many as I can fit on my graph. Okay. Now I need to know what kind of a line I'm drawing, so I go back and I say, what does this final answer tell me? It tells me it's dotted. Ooh, that's so fat, I can't even write. Dotted, and it's less than, so we are shading below. So dotted and below. So we'll pick the dotted line. And we have to shade below. So again, the ground of this hill is down here, so that's where your shading needs to be. Okay, that's it. 6 is your homework worksheet.